And welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the bunker. No Starfield in the background today. We're going to tell you all kinds of reasons why you, too, should be in a bunker instead of doing lovely things like going outside and enjoying a delightful bike ride on such a temperate day early in April. Bunker time. Rapid uptick in sunspot number for all of you folks who are frightened of active stars. Definitely it's bunker time. We'll talk about a bunker timeshare a little bit later. Yeah, bunker timeshares, folks. That's a real disaster plan for you. That's a 24-hour video from SDO, by the way. It's 30 frames per second, featuring the 171 angstroms wavelength as well as the 193 angstroms 60-minute running difference. You may see a CME popping off there, kind of right in the northern part of the Earth-facing solar disk. It was mostly a filament collapse. There was some ejecta. You're probably wondering if it's earthly directed. Will that be yet another reason to live in a bunker instead of making hay while the sun shines? And it does. It's a cliffhanger. And here we've subtracted the 193 angstroms for the house favorite wavelength. And again, we do have somewhat of an uptick in sunspot number since yesterday. Here's another classic wavelength, the ever-popular 304 angstroms. And look at that filament staying very tightly bound together and looking like it's just moving off to the east. We'll talk about it more in a moment. But first, check out the 335 angstroms wavelength. We did have an M-class flare, so the uptick in solar activity now happening in earnest. And we've got, again, new sunspots and so on. We'll get to it. First, let's take a brief look at planet Earth. And before that, don't forget to press the like button. If you're new to the channel, press the subscribe button. It's only the world's most comprehensive daily space weather content. Who would ever want such a thing? I mean, it's called forward-thinking content, folks. Forward-thinking content. So, cheers. Congratulations on realizing the channel exists. Smash News Network is the least busted name in news. The Iceland eruption continues, but it is simmering down. So it's still quite a spectacle as this fountainous hellscape continues. But yeah, things are dying down there near the town of Grindavik as molten lava, as magma becomes lava before your very eyes. And if you know the difference between magma and lava, let us know in the comments. Etna had some seismic activity happening. So there are some volcanic tremors happening there on the Isle of Sicily. Sakurajima also probably erupting, but volcanic ash not identifiable. It's probably a cloudy day on Kyushu. Mount Ibu's exploding. Luitobi produced a 7,000-foot ash plume. Semaru exploding. Merapi, Popocatépetl, Sancho Guido, Fuego, Navarro del Ruiz, Ravenador, and Sabancaya. Although only steam and gas coming out of Sabancaya, please do not pole vault the caldera. Continuing right along to our seismic activity. That's what's been going on for the past 90 days. And things have calmed down since a series of quakes have been kicking off. Solar activity is up. Earthquake activity is down. 5.2 at the Philippines. One of the only 5 and greater magnitude quakes, maybe the only. Oh, also a 5.0 aftershock there at the Philippines. Well, it's pretty far south of there. Let's call it a separate event and move on to some more stats, like the radio flux, which is now up to, what is it up to? 131. There you go, 131 solar flux units is the radio flux. And folks, if somebody tells you that you ought to enter a bunker because of the radio flux number, and they don't give you units, if they say, oh, the radio flux is at 200, Everything has to have units, folks. In science, if somebody just says a number and says, be spooked of this number, don't be spooked of the number. But get in your bunker, for sure. Definitely get in your bunker. So there's the past year of radio flux depicted by the black line. It is the most proportional set of data we have to the sunspot number, which we'll get to. First, we'll look at some geospace stuff. There is NOAA's forecast and no space weather in the forecast, although we do currently see a slightly elevated solar wind velocity. So it's that weak coronal hole high-speed stream continuing, and it's, well, like I said, weak. Weak sauce. So, let's see if ESA is forecasting that CME that we showed you at the beginning of the video is earthly directed. The answer is, I don't think so. Definitely not. So that's ESA's stance on it, and I've got a stance on it too. I could have sworn it showed a glancing blow. Let me look at that again. I think it's actually showing a coronal hole high-speed stream again. So, yeah, not expecting a CME impact is ESA. Next, Earth's magnetic moment from space for the past 4 hours. The space weather modeling framework is depicting out to about 12 Earth diameters. So it's showing a model of the likely magnetohydrodynamic pressure in the earthly system. That's the past 4 hours of magnetohydrodynamic pressure. At the ground level, it's showing magnetic perturbations. These are the places where you'd be likely to see the aurora, have telluric currents, induction into power grids, pipelines and railways, and so forth. Geospace delta B refers to changes to the Earth's B field. And if you want to know what a B field is, it's the field that goes through the magnet. We'll show you some solar B fields momentarily. Planetary K-index is at 1.33. Very geomagnetically calm. That elevated solar wind isn't doing much. It's got to be quite diffuse. So there is the solar wind data from ACE, showing below, just barely around 400 kilometers per second, right around 400 kilometers a second there. Make it 430. But, like I said, diffuse, only 1.1 protons per cubic centimeter. At the Discover, quite a bit different values showing up here at the Discover. The Discover is, man, oh man. Am I going to be required to smash some electronics today? Because there could be sledgehammer use. All right. Discover showing 440 kilometers per second at 5.1 protons per cubic centimeter. Once again, folks, understand the units. Understand what you're talking about when it comes to things like the solar wind. So yeah, it's pretty nominal. That's barely a coronal hole high-speed stream at all. GOES magnetometers here are smooth. We ain't got no space weather storms or any on the way. We do have some magnetic sector crossings happening. So there's the heliosphere, and it looks like that South Pole magnetic sector has extended, so Earth can expect to be in a South Pole magnetic sector here for as long as a week or so. So expect South Pole-oriented coronal holes rotating in. South Pole coronal holes are on the forecast because that data right there is very much legit. This is one of the best pieces of forecasting data you could possibly have. It will tell you things that you cannot discern by just looking at the imagery. Even looking at sunspots, that is superior to looking at far-side sunspots. Using helioseismography, yes, it's better. That is superior. We've shown how it can be used to forecast for years on the channel. So here's the sun's B field, right? The field that goes through the magnet, this magnet being the sun. The B field shown in blue, photosphere magnetism in gray, and polar fields in green and red for north and south, respectively. That's a lot of information. That's 4 days worth. Coronal holes are next, and again, you'll see South Pole-oriented coronal holes rotating in here undoubtedly, and indeed you do. So understand the physics, understand the data correlations, understand how to forecast. That's the way things work. And before we do anything like that, let's move on to take a look at coronal holes. Yes. 211 angstroms. And here's the coronal hole that ESA is forecasting will provide a little bit of an uptick in geomagnetic activity. In about 5 days, we'll expect to see. I don't know. That seems like a bizarre forecast. Doesn't look right. We should get this. If there is a solar wind from that, an enhancement from that coronal hole, it should show up earlier than 5 days from now. But hey, what can you say? I didn't make the forecast. I'd say that'll be more like 3.5 days out, but that's just my opinion. And let's move on to sunspots. So yeah, marked increase in sunspots here. No real surprise there, as we are still like 6 months out from solar maximum. So there you go, an increase in sunspots. That's absolutely not of any surprise to anybody who has any clue what they're talking about. Yeah, sunspot number now back to 90. Back to 90 sunspots there, maybe 89. Wouldn't want to cherry pick data. Like people who claim the sun is shutting down. They look at 180 sunspots and they say, look, there are no sunspots. I mean, talk about some functional blindness. I mean, geez. I know your cult is very important to you, but you should exit your cult if you think the sun is shutting down. It's... yeah, Scott McIntosh isn't incorrect about his forecasting. All right, so sunspots and... again, a marked increase, much higher likelihood of large solar flares. We've got a number of players now. 3635 has already produced an M-class flare. 3634 is looking more and more complex, although it's a little bit evenly distributed. So that has a tendency to sort of cancel each other out, it seems, when it comes to sunspots. In other words, when they're very symmetrical, sunspots have a tendency to not flare very much. What you want to see is disproportional magnetic fields, like in the one field versus the other. That's... you want the fields close together, and you want them opposite polarity in close proximity. That's the optimal situation for large solar flares. And yeah, but there could be some stuff rising there quite a bit of stuff rising in the east. We'll look at high-res imagery here momentarily, but first, some SDO imagery, courtesy of the Smash News Network, least busted name in news, and of course, helioviewer.org. So there you go. There's a sort of an equatorial zoom. And here's an extreme close-up. Now, we did rotate the field of view there, so it's not really stationary, but the field of view is rotating to show you the way those umbrae are moving in relation to each other. So we do have a little bit of a disparity of the leading North Pole umbrae there, but they're quite far apart from each other. That might only be a beta class or a beta gamma class. I don't think it's a beta gamma delta class. And there's the magnetogram, and again, I don't think it's beta gamma delta class. We'll take a look at it toward the end of the video and, sort of make sure, but yeah, I don't think so. Sorry to say, folks, I don't think it's beta gamma delta class. Yes, we hope for solar flares on the channel. We are not spooked of solar flares, although if you are, definitely bunker timeshare. Get in the bunker timeshare, because what you want to do is you want to share your timeshare with people who are spooked of an inactive sun, right? So you want at least 2 timeshare owners, or 2 groups of owners even. Half of you want to be in the bunker when the sun is active. The other half, if you want to be in the bunker when the sun is inactive. And this way, you'll maximize your bunker timeshare. That is a real disaster plan. Now, come on, folks. Bunker timeshare for the win. Maybe I'll invest in a year or 2. So yeah, I mean, let's do it. Let's create a brand, bunker timeshare. We'll buy some underground rocket silos or something and outfit them for glamping, and then of course we'll create a bunker timeshare organization. That sounds like a brilliant scheme. I mean, solution, right? So there are solar energetic particles, and we ain't got none. It's flatline. But there has been an M-class flare. It was right around 1700 Universal Time. It was an M5.5 almost. So almost an M5.5, which would have triggered some NOAA warnings, but not quite, only a 5.47. That's still not too shabby, right? So now again, no stars today, no stars, because we're in the bunker. So you got to broadcast from the bunker sometimes. You got to make sure that the Smash News Network, least busted name of news, is prepared to lock ourselves in a subterranean abyss. And of course, at the end of the videos, you may hear me occasionally, jumping down into the bunker because we don't have a fire pole. We have the SBAS, the Swamp-Based Acceleration Reduction, SBARS, Swamp-Based Acceleration Reduction System. Basically, there's a giant mud hole in the basement. It's totally sweet. Anyway, the M-class flare did come from that northeastern area there. That's one of them sunspots with names that I don't memorize. And but yeah, that's another 24-hour video from SDO, 131 angstroms. And there's actually multiple events going on at the same time here. It's pretty cool because you've got sort of a simultaneous series of events happening around the same time. And this is a regular thing that you see because waves ripple across the apparent surface, the real surface of the closest star, and that has a tendency to cause flaring to happen in multiple spots. So when you see something happening on the far side, sometimes there's something very similar happening on the near side and so forth. That's just the way it works. Because it's, this is an indication that the sun has a real surface, not an illusory surface. And of course, I won't get into the gaseous plasmas, the issues with the gaseous plasmas that are myriad. But yeah, anyway, let's move on, because we don't want the video to be too lengthy here at the Smash News Network. Please post the name of news. So yeah, a little uptick in solar flare activity. And how about 94 angstroms, SDO? Yeah, 94 angstroms is pretty sweet. And we've slowed that down right around the time of that flare. Again, that M-class flare came from that northeastern limb, but you can see multiple flares from multiple locations there. So there's a flare behind the limb down here in the southeast. There's one here in the northeast. There's even one here on the northwest. So this is, again, a common thing that we see regularly. Flares happening in multiple locations, or CMEs happening in multiple locations. That's a thing that happens all the time. And it's actually quite common. It's just not always apparent because we're usually looking at the features on the Earth side of the disk and not paying that much attention to the things on the far side of the disk. Anyway, let's see. We've also got, there's your star chart, or your solar system forecast. That's where things will be in a week on April 18th. And there is the star chart. So that's what's going on over our head. If you want to make your own, head to skyandtelescope.org. Skyandtelescope.org. We're not paid to say it. It's just a good recommendation. I mean, drop us a line, skyandtelescope.org. We'll have your webmaster on the channel or something. Cheers. And if you're not sick of eclipse pics yet, make sure you stay tuned for this section, because we've got some eclipse pics complete with sunspots there. So that may be appealing, that may be annoying, I don't know. We're just going to show it. It is the apod.nasa.gov astronomy photo of the day, and a pretty good image there of the corona. Now you can see the location of coronal holes here. So right down here, there's definitely a coronal hole in that area. And of course, you can actually look at features from different SDO wavelengths and even figure out which way the sun is oriented from the perspective of that photograph. Keep in mind, when the sun and moon go across the sky, they rotate like a wheel. So it can be a little bit deceptive, the orientation that you're viewing it from. It may be instinctive to think that the top of the sun is going to be north from your perspective, but that's not really the way it works. It's a little more complex than that. But yeah, there you go, the astronomy photo of the day, apod.nasa.gov. Next, CMEs. So, again, we've had some. Are they earthly directed? The answer is no. They're not. Quite sure that they're not earthly directed. So that's 81 frames from today. And I changed my mind. There is an earthly directed component. Most will miss to the east. Most will miss to the east. But there will be a minor impact. I think it could mainly just be characterized by magnetic fields. Sometimes you get a CME impact where it does affect things, but you barely see a particle impact. That's a thing, because keep in mind the magnetic field extends beyond the particles, and that could be a thing that happens. But it's not going to be a direct impact at all. Glancing blow at best, possibly a nothing, but it is quite high speed. Expect that in 2 days or possibly even less. So sometime on the 13th, that is likely to show up. Just a minor brush by, I would suspect. So here we've just paused this just to show those CMEs, and they're quite deceptive. I mean, they look a little bit differently from stereo A's perspective, which we'll show you here in a minute. There's actually two separate events there kind of popping off. And the one that you see around 10 o'clock Universal Time, that is the one that has an earthly directed component, it looks like. So here's stereo A and its difference imagery over here on the right. So that it's quite a concentrated CME there, but because it originated practically right in the middle of the solar disk, it is a little bit north of the equator, quite a bit north of the equator, but still, it's moving to the south, so it's fair to think that there would be an earthly directed component there. Keep in mind, it's a little deceptive when a thing is moving directly toward you. So, and before we get to filaments, let's take a look at our custom coronagraphs. How about them apples? Welcome to the Smash News Network, least busted name in news. So there are the custom coronagraphs. Not half bad. Synced up the SDO 304 angstroms with the Soho Lasco C2 and C3. Very nice. Very nice as we bring you the world's most comprehensive daily space weather content and the most detailed solar imagery. So you can't expect to do something like the daily space weather show and be lazy. It's pretty complicated. And I mean, I invite you to go check out the, quote, competition, end quote, because there may be some very high comedic value. So huge streamer about to rise over here. Check it out. That's a massive, massive streamer right there. You can expect to see that eject pretty soon. And we're hoping it rotates a little bit further around to the Earth side of the disk before doing so, since we hope for CME impacts on the channel. We find that kind of stuff to be fun. It is bunker worthy. I'm sorry, I forgot. Definitely get in the bunker when you see something like that happen. Oh no! Oh, spooky, spooky space plasma. It's magic. It's quantum mechanical magical vibrations, folks. It's magical vibrational frequencies. When that thing happened, my cat ran away at the same time. It's the sun's fault. The sun did it. The sun caused my cat to run away. By the way, if you want to check out the videos yourself, check out helioviewer.org. You can make your own videos like this, but not if you're lazy and useless. You definitely can't do it if you're lazy and useless, because you will not have the determination to do so. So anyway, filaments are next, and filaments are important, and one of them ejected. It's this one right here, I think, and it's there, and now it's gone or something. Let's look at the colored imagery. Wait a minute. Oh yeah, see that huge prominence up there? Also a huge prominence down here. So it looks like multiple new active regions are about to rise. Here is our colored imagery from Cerro Tololo also. And the filament's there, and whoop. Oh wait, I think it's actually this one, right? Oh, this one. How about that? You see, you should have named that filament, because then you could track yourself through the solar system. Anyway, if you want to name filaments after living people, join us over on Twitter. Otherwise, you won't see important posts like this. If the determination in those eyes doesn't say enough. Hold on. Let's try that again. If the determination in those eyes doesn't say enough. The power of those words will be the wordiest words ever diversely worded. Now, where would you get tidbits of wisdom like that if you didn't follow us on X? There was a video that I was promoting that I think I shared it in the community posts on YouTube. YouTube.com/smashomash/community. Are you part of a community that lives in a bunker? Let us know in the comments. Have you bunkered up? Have you and your best pals, have you bunkered up? Here come bonus features, starting with the GO 16 SUVi. Again, multiple places where we could see large solar flares. Moving on to the bonus features, satellite charging hazards are first. We ain't got none. The GO's Electron Flux is next. If you need to pause it on that frame, feel free. We're in a nominal range. There is the very moderate range for the past year, but that we're in now, at least. That's the past year to contextualize it. There's the NOAA forecast, and I have no arguments, no complaints, no concerns about that in any way. Here's the ionosphere, and we're showing the vibrational frequency, the ionosonde, as it's called. Keep in mind that gas is very diffuse, and that is at the bridge between Earth and space. Also keep in mind that it's very easy to vibrate a tiny amount of gas like that, and very hard to vibrate a lot of gas down at sea level. It's like something like a quadrillionth, 10 trillion to a quadrillionth more dense at the surface than it is at the F layer of the ionosphere. So it's very, very diffuse up there. But there it is, shaken at 1 million vibrations per second plus, the F layer. If you're not used to looking at that, here's the anomalygram. That's anomaly in megahertz from a 30-day median, depicting low-frequency anomaly in red and high-frequency anomaly in blue. So it's pretty run-of-the-mill. It's not bunker-worthy. All right, definitely. Tell your friends and foes that we told you that you should hide in your bunker based on that data. It's just show people that and say, oh, look how spooky it looks. Look at that. Look at that low-frequency anomaly crossing the Atlantic Ocean. Oh, my God, it's a spooky, spooky bridge. I apologize. And, of course, the total electron content may make you decide to enter a bunker as well. So that's depicted on the left. And you may have trouble communicating with people in other bunkers using your ham radio. So see where you may run into problems with that by viewing the imagery on the right. That's the WHAM, the whole atmosphere model. Not to be confused with George Michael's band from the 1980s. The famous author of great hits like Wake Me Up Before You Go Go, Careless Whisper, and Faith. Wait, that was solo. Anyway, here is our here is the latest thingy. And let's take a look at this sunspot since we showed it earlier. Well, it's pretty impressive. I mean, I can't complain. Not really, it's beta gamma class. I'll give it beta gamma class, not beta gamma delta class. This one over here, what's up with that? Let's take a look. Let's try that again because I moved the freaking mouse. There we go. That one's certainly beta gamma class. Is it beta gamma delta class? Barely. No, it's not even beta gamma delta class. But things could be looking up for it. So it's something to keep an eye on. And when I say eye on, well, the pun was intentional. So, moving on to Earth weather. And look at that. Earth has a tumor. What is going on? What is happening? Earth has a planter's wart. Just kidding, folks. That's a UV index. And, of course, this area right here, that is a gateway to hell. Because, that's an area where darkness lies. Darkness lies like people who lie to you about space weather. Yes. Look at this. Look at how dark. Oh, my God. What could be going on there? Does anybody have any idea what could be going on in this dark, dark place in the middle of the Pacific Ocean? Obviously, it's a gateway to hell, right? Just kidding, folks. It's caused by clouds. That's what causes these spooky things to happen. Now we're showing total cloud water. And yeah, look, the CAPE index. Oh, let's talk about total precipitable water. Oh, my God. The craziest part is the atmosphere is actually less dense in that area. How do you like them apples? Total cloud water. Yes, the UV is lower. The cloud cover is higher. And let's just move on. Yes, definitely get in a bunker because of that series of clouds in the Pacific Ocean. Clouds in the Pacific Ocean are definitely a reason to bunker up. These are the surface winds of the east, jet streams of the central world, surface winds of the west, and our jet streams, and close out that thing, and then move on to show the satellite imagery. Satellite imagery there, courtesy of the NASA GOES Interactive Weather Satellite Suite. Once again, monoliths showing up. Let us know in the comments if you think they're full of stars. So, people in the Northeast may not be liking the weather right now because there's a bunch of moisture and it's a lovely day out. And of course, you want to be outside when it's a lovely day out, but you aren't because you're worried that's going to rain and you don't know how to forecast the weather, but you should. Anyway, the low that's affecting the weather in the northern and really the whole eastern part of the country is this low that's just south of Detroit. So that's what's in control of things. That's windy.com. They got a free mobile app if you want to download it, or if you're going to say it's not free because it's spyware or something like that, then feel free to do so in the comments and let us know how mad you are that it gathers data information about you and metadata and oh my god, dear god. So anyway, we're just scrolling down to show you the key there so that if your location is lit, if you're lit enough to go to weather.gov instead of relying on this perfunctory forecast of the lower 48 and even Alaska and Hawaii showing up there, some winter storm warnings in portions of Alaska where nobody lives, or very few people live. Anyway, here come your weather forecast. That's 72-hour GFS temperature, and that's what? Pressure and precipitation. Yeah, that's what it is. And that low is just going to kind of stall around eastern Canada there and then make its way to the north as the Pacific Northwest continues to get pummeled with wave after wave of Pacific moisture. The Bonsai Express. And of course, here is our total accumulated precip as California gets drenched over and over and over and over. It's kind of moist. Parts of Pennsylvania expecting like 4 inches of rain. Also parts of Canada. 72-hour GFS total accumulated precipitation forecast in inches. Temperature anomaly forecast in degrees Celsius is next. Once again, the GFS 72-hour model. Some very warm air going to move across Wyoming into South Dakota and then cool down a bit, but still unseasonably warm temperatures coming while it stays cold in California. Anyway, we've got lightning, and there's a bunch moving across Florida. Shout out to residents of Oviedo. You may have had a thunderstorm. And anyway, here's our real-time lightning map, courtesy of lightningmaps.org. Next time you hear thunder, it's highly recommended. What do you got? What do you got? Oh my god, the Avon Park Air Force Range has lightning adjacent to it. And you know what that means, folks. Bunker up. Bunker up. Make sure you drop us a line and we'll keep you posted about the bunker timeshare business that is about to erupt. From under. Get it? From under? It's like a bidet. It's like a bidet of evil. It's like being showered with evil, only from underneath. Like a bidet. Like a bidet of evil. Bunker timeshare, folks. What could possibly go wrong with a bunker timeshare? It seems like just a brilliant idea. Maybe we can ask some other YouTube channels about it. So there's our Doppler radar for the U.S., the full 50-state view. We'll focus on the lower 48 view. We'll show the satellite, and we'll show the water vapor as that low makes its way to the Great Lakes. It's just about to make it to Detroit, just south of Detroit. No offense to residents of Detroit. Here is our satellite image from the NASA GOES Interactive Weather Satellite Suite. How sweet it is, visible satellite. And last but not least, the water vapor. So it's getting quite an impulse there of warm but massive air. Since nitrogen is more massive than water, that's atmospheric nitrogen, which is N2, is less massive than H2O. Anyway, that's about where we'll close this thing out. But thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash. And may that solar wind be at your back. Now it's time to use the SBARS, the S-bars, the Swamp-Based Acceleration Reduction System. See ya. No fire pole here, because I'm going to the level 3 bunker. So, ta-ta. Whoa.